Good afternoon and welcome to your science review with Mr. Blades. Today we're going to be using a velocity versus time graph to calculate force. So let's get started. Now you can see that I've drawn the graph and that it has three sections, A, B, and C. Now we're going to use our force equation, F equals ma, to solve for our force. Now we've already been given our mass and now we're going to use our graph to figure out our acceleration. So let's go. Our acceleration equation, as you'll remember, is delta v over delta t, or v2 minus v1 over t2 minus t1. Our v2 in part A is 20, our v1 is 0, our t2 is 10, and our t1 is 0. So that gives us an acceleration of 2 meters per second squared. Now if we plug that into our force equation, we get F equals 10 kilograms multiplied by 2 meters per second squared, and that gives us a net force of 20 newtons. Now we're going to go ahead and do the same thing over on part B, and let's start with our acceleration equation, delta v over delta t, but in this case our v2 is 20 and our v1 is 20, divided by our t2 of 15 minus our t1 of 10, and that gives us 0 over 5, or 0. Now if we plug that into our equation, we get F equals our mass times 0, and we can see that gives us 0, a net force of 0. With no acceleration, there is no force. So let's go ahead and do part C. Start off the same way. Acceleration equals delta v over delta t, but in this case our v2 is 0 and our v1 is 20, so 0 minus 20, divided by our t2 of 30 minus our t1 of 15. That gives us negative 20 divided by 5 seconds, or 1.33 repeating meters per second squared. Now if we plug that into our equation, F equals 10 kilograms times 1.33 negative repeating meters per second squared, and that gives us a negative 13.33 newtons. That negative, of course, refers to its direction. This is how we use a motion graph to solve for force. I hope this was helpful, and I'll see you in class.